Okay, so in this section, this is section 1.3, just dealing with complex numbers or imaginary numbers. Okay, so so in this case, this is some of the information they tell us about this. Um, I square is equal to -1. So we have to, in anything that you do, you have to have an axiom, so a common base that everybody agrees on. So in this case, they tell us that I square is equal to -1. All right. And then we would write this in standard form, our answer. So this is in standard form, a plus bi. Let me write that down here. This is in standard form. Okay. A plus bi. So a and b are real numbers and I is an imaginary number. So let's look at a kind of a concrete example. Okay. So this um, complex number, or in this case, this complex example, 3 plus 2i, is represented by this. If you remember a movie, Despicable Me, right? In the first one, there is a villain there. And does anybody remember what the villain's name is on the first Despicable Me? Yes, very good. Vector, right? So, One way to one way, that's how I always remember it. Okay. So Vector, remember in the movie, he what introduces himself as what? Having direction and magnitude. Okay. Vector introduces himself having direction and magnitude. So in this case, it's the same thing. There is a direction, it goes some kind of direction, and it has magnitude, meaning there is a length to that. So that's how I remember this. So 3 plus 2i is represented by this vector. Okay, you go over 3 and up 2. So that's one way to look at it. Okay. All right. So here is our imaginary. Okay. We have I1 is equal to something, and then I square, we already know what that is, right? It tells us I square is equal to -1. Okay. I to the 1 is actually just I. All right. And we're going to see a pattern here in a second. Then I to the 3. Okay. What would be I to the 3? Well, if I break I to the 3 down, right? So remember, the rule is, right, if I have, say, x to the third power times x squared, I would have x to the fifth because I just add the powers, right? That'll give me x to the fifth. Does that, okay? All right, so that's what I can do here. So here I have I squared times I to the 1 because 2 plus 1 will give me 3. Okay, just like here. Okay, so we know what I square is. I square is -1. So let's write -1 here. Okay. And then times I. Well, what is I? Well, it's just I. So I times -1 is just -I. So the answer to I cube is -I. Okay. Let's look at I4. I to the fourth. Again, there's a lot of ways to do this. I don't have to do one particular way. There's whatever works with your brain. Well, I notice I to the fourth. I can rewrite that as I squared times I squared. Okay. Because 2 plus 2 will give me 4. So I already know what I square is. I square is what? -1. All right. And another I square is -1. So that gives us what? -1 times -1 will be a positive 1. Okay. And that will be our answer there. Okay. Any questions so far? Okay. So why don't you guys try it? I'll have I to the fifth, I to the sixth, I to the seventh, I to the eighth. And let's see if you see a pattern. All right, so I forgot to press record here, so I'm going to just do a recap of this slide and then go on to the next slide. So I believe we went through I through 4, and and then we found out that I5, when we break it down to I square I3, we get I, right? Because we already know what these are. I squared was -1, I3 is -I. So -1 times -I will be positive I. Then I just go through the same process for the other ones. So I6 I broke down to I squared I4 because 2 plus 4 is 6. I7 I broke it down to I squared times I5. So that's 2 plus 5, which is 7. And then I8 is I to the 4 times I to the 4. So 4 plus 4 will give us 8. Okay, so we get j -1, -I, and 1. And originally we also got j -1, -I, and 1. So if we were to put this on a coordinate plane, 1 here being on the x-axis, on the y-axis is I. So the opposite of 1 is going to be -1, and the opposite of I is going to be -I. So if we started at I, right, we got I here as I1. I squared is -1, I to the third is -I to the fourth is 1. Then we go back. I to the fifth is I to the sixth is -1, I to the seventh is -I, and I to the eighth is 1. So anyway, so it just follows that pattern, okay, over and over. Now, when we're simplifying these complex expressions, they want us to write it in standard form, which is a plus bi. So that means you can either have positive or negative. It doesn't have to be all positive here. It can be either negative or positive. So when I do this, so let's say I have 4 plus 5i plus 8 negative plus -8 plus 2i. If I just change the I to x's, I can easily simplify this, right? Because 4 plus -8 will give me -4, and 5x plus 2x will give me 7x. So I'm just combining like terms. I'm going to do exactly the same thing for imaginary. I'm going to have 4 plus -8, which is -4, and -5 plus 2i is going to give us 7i. Okay? So our answer here will be -4 plus 7i. Now, let's look at this next example. We have 3 minus 4i minus minus times -3 minus 4i. So the first thing here is we need to distribute that -1, okay? When we get that, we get a +3 and a +4i. And then we just bring down whatever we have in the front as our expression, which is 3 minus 4i. Then we combine like terms. So 3 plus 3 is 6, -4i plus 4i is going to give us 0i. So 6 plus 0i is 6. Now for the last one here, we got 3i times -3 plus 4i. I do the same thing. I'm going to distribute the 3i. So that gives us -9i plus 12i squared. Well, what is I squared? Well, it's -1. Okay. So we're going to have -9i plus 12 times -1, or -9i minus 12. Or I can write it as -12 minus 9i. Okay, because that would be in standard form.